Welcome back. In this lesson, we're going to look at change of state. So if you have a material that you give thermal energy to by heating it up, you can take that solid piece of iron and melt it into molten iron. They do that at a steel plant. And then if you gave it sufficient energy, like you threw it into the sun, it would have enough energy to turn into a gas. You would have gaseous iron, just like you could have liquid iron. We know the best probably in terms of ice. Ice can melt into water. Water can then boil into steam. And so water can be a solid or a liquid or a gas, usually having to do with temperature. And so we're going to look today at the changes of state. We're going to see that there's energy involved in each of these changes. You either absorb energy by going from a solid to a liquid to a gas, or releasing energy as you go from a gas to a liquid or a liquid to a solid. So let's look at some of the examples. It has a very low energy, and they're not hyper in any way. They will assemble themselves in a regular pattern, in a matrix pattern. And a lot of solids are crystals for that reason. Crystals are very organized place where you put everything in its place. Imagine all the crayons in your crayon box exactly the way they came. That would be a matrix. And so a solid often is going to be of low energy, and that low thermal energy means that the atoms or the molecules are closely, densely packed. If you give more energy to it in the form of heat, so heat energy, then what will happen is that those molecules or those atoms are going to not be so bound together, and they're going to have enough energy to slide past each other. So in a liquid, those molecules have sufficient energy not to bounce off the walls, but at least to slip and slide past each other. So a liquid has a definite volume, but it doesn't have a definite shape. It can, since they can slide past each other, they would take whatever shape of the container it's in. A solid is going to have a definite volume and a definite shape. So when you increase the thermal energy such that it would be a gas, then there's no connection or attraction between these various molecules. They have escaped that attractive force, and they are free to bounce off the walls, off the floors, off the ceilings. And so for that reason, they have no definite shape, and they have no definite volume. They're as far away from each other as they can be inside whatever container that they're in. There is a fourth state of matter. If you were to increase the energy enough, like really, really hot, or in some ways scrape, let's say a gas together, maybe in a thundercloud, they would be scraped together. What you're going to end up with is ionized gas. And remember, an ion is either more positive because it's lost electrons, or more negative because it's gained electrons. For that reason, a plasma can conduct electricity, and that's why a thundercloud can produce a lightning bolt, because the gases that are in that cloud have been scraped due to the winds that are blowing around. The electrons are scraped off of those molecules, and now you end up with positives and negatives, and now electricity can flow. So a lot of this change in state has to do with heat. It has to do with energy. And there's ways that you can change state without changing temperature. For instance, at 0 degrees Celsius or 32 degrees Fahrenheit, ice will melt into water, okay, at that temperature. But at that same temperature, 32 or 0 Celsius, water freezes into ice. So it's the same temperature, but one can be liquid, one can be solid. The liquid has more energy in it. So in order to freeze water into a solid ice, it has to let off a lot of energy. It has to cool. It's funny because it's cooling, but it's still 0. It doesn't change the temperature. It's just dumped some of its energy. But for me, it's easier to think of temperature in terms of change of energy. Okay, so if I take solid ice and I put it in a warm room by increasing its thermal energy, then it melts into water. If I increase the energy of that water by putting it on the stove, it will boil into gas. If I were to somehow suck the energy out of that gas, it would condense back into water. For instance, if you ever had steam in the bathroom and that steam hits the mirror and the mirror's cold, it'll suck the energy out of that steamy air and turn that back into liquid water. And that's why you have like a mist or fog on your mirrors. Same thing. And the same thing happens when you take water and you put it back into ice. It has to release its energy. So when it's going up towards gas, it's going to absorb energy. As it's going back towards solid, it dumps its energy. So you end up with 3 states of matter that can interconnect. They can go from one to another. Liquid, that's called melting. If you have liquid and it goes to solid, that's freezing. And most people know that really well. If you were to have gas, say the steamy air in the shower, and it hits the mirror and turns back into liquid, that's condensing. You condense that water. It's condensation. In fact, the fog on your mirror or on your windows is called condensation. So a lot of people know that one. If you go from a liquid to a gas, most people would say boil. Boil is when every single molecule of water in a sample has enough energy to escape. That's boiling. Vaporization is just when one molecule has enough energy to escape it into the gas. So whatever on the surface of that glass of water, if you were to put a glass of water on the counter, in a few days it would be lower because every once in a while that one water molecule on the top has sufficient energy to escape into a gas. It didn't boil, it just evaporated. So evaporation or vaporization is turning liquid to gas. And then boiling is a specific form of vaporization where every single molecule has sufficient energy to escape into a gas. Now the hard ones is from a gas to a solid because you don't always see it. If you've ever opened up a old refrigerator freezer and you had frost in the freezer, well, that frost came from the air. When you open the freezer, there was air that had water in it, and that water turned instantly to ice. That's called deposition. Okay, so if you were you had sufficient cold and you were to turn a gaseous water vapor immediately into solid without turning into a liquid first, that's called deposition. And then its opposite is sublimation. If you've ever seen a February day to where there was snow on the ground and it never really melted, but yet tomorrow there's less snow. Just the sunlight seemed to melt the snow without turning it into water. It sublimed it. It turned it straight from solid into gas if you had enough energy. Now, one of the fundamental laws in science is called the conservation of energy, or the first law of thermodynamics. And that means that energy cannot be created and it can't be destroyed. The same amount of energy that the universe had at the beginning is the same amount of energy it has now and will ever have, because it can be changed from one form to another. You can change one type of electrical energy into thermal energy, or thermal energy into all different kinds of interchanges, but you're going to have the same amount. You can't create energy simply by doing some kind of an experiment. You can't lose energy. You can convert it into heat and then maybe not be able to get it back. If the universe somehow warms up and you can't get that energy back, you've in some ways lost it, but it's still there. It's just lost to us. So that's called the conservation of energy.